Okay, it's exercise 11.4, question 2. We need to prove that triangle APQ is similar to triangle ABC. I'm just going to draw the triangles down here. Can everyone please copy these out if you haven't done this already? Now, girls, the two triangles are overlapping. So when the two triangles overlap, it is a really good idea that you draw them separately. So part A of the question is to prove that triangle APQ is similar to triangle ABC. I'll do part B in a minute. Girls, if I were you, I would draw the two triangles separately, even after you've done the proof, all right? Now, you have to prove that APQ, the small triangle, is similar to the large one, ABC. All right, for those that did it, what did you do for, so you say in triangle APQ and triangle ABC. What have you got?
Angle ABC equals angle APQ.
Okay, yes, so angle ABC.
Equals angle APQ.
So those two angles are equal, reason? Yeah, so I've got angle APQ equals angle ABC, reason corresponding. No, it's written on there at the moment. Corresponding angles.
PQ parallel to BC.
PQ is parallel to BC. Girls, what else can we say?
Angle BAC equals angle PAQ.
Good. This angle up here, if I was to draw the two triangles separately, what's the reason for that one? Yeah, so angle PAQ is equal to angle BAC, and the reason is that angle A is common. It's the same angle for both of them. Girls, it is enough to do equiangular. You only need two angles, but if you feel the need, you can do the third angle, but you don't have to. Because if two angles are equal, then automatically the third angles will be equal. So you don't have to do three angles for equiangular. It's enough to do two angles. Okay? I mean, if you want, you can do angle AQP is equal to angle ACB, again, corresponding angles, but it is not necessary. You don't need to do it. So, therefore, I've got these with crosses. So I've got three angles in the small triangle are equal to three angles in the large triangle. So what is the reason that these two triangles are similar? Equiangular. Good. Equiangular, meaning that all the angles are the same. Now that's part A. Part B says, hence find PQ, hence find the length of PQ, AQ, and QC. So you have to find all those side lengths. Now this is where I really want you to draw the triangles separately. So I'm going to draw the small triangle here, APQ, with all its markings, arc, dot, cross, and put in the side lengths. This one's 10, that's all I know. It's really, really important to do this, girls. Please don't be lazy. All right, then I've got big triangle is ABC. What lengths can I put for AB? How long is AB? No. AB, this one. 10 plus 8 is 18. Good. What about this one, AC? 22.5. And what about BC?
27.
And I'm going to put the markings on there as well. So, okay, girls, I don't think you've got, we do know, but that AQ, we don't know what this length is, all right? But I think we've got enough because we've got one complete pair. See how 10 and 18 are a match?
Yeah.
Why? Because we've got arc dot, arc dot. So 10 and 18 are a match here. So we are able to find the other side lengths because of this. So first one, let's find PQ. So we write that one first. What's PQ's matching side?
27.
So PQ over BC. I'd like you to, girls, listen. Are you listening?
Yes.
Right. Rather than putting values first up, I'd like you to state the sides. So PQ matches with BC. So we're going from first triangle over second triangle, and now pick me another two sides that you know. that match. See, PQ over BC equals, what do I write? So that over that, why am I choosing PQ first? Because I'm trying to find PQ. So PQ matches with 27 equals, I need another set that matches between the two triangles. What's a matching set? They're a matching set, but that's the one you want. 10 and 18. So equals AP over AB. I'll put the numbers in a minute. Why am I writing that?
So we know what you're talking about.
Yeah, the thing is, yes, in the HSC, girls, they want the sides. Don't just put values in. Ones if there was another side with that was 10 or something like that. So I want PQ matches with 27 and 10 matches with 18. So that's PQ over BC equals AP over AB. Why am I writing that statement? Matching sides or corresponding sides. If you don't want to use the word corresponding because we use it in parallel lines, you might choose to use the word matching. So matching sides of similar triangles are in the same ratio or in proportion or same ratio. In proportion.
Could we just write matching sides of similar?
Not enough. Matching sides of similar triangles would mean that they're equal. So I want matching sides of similar triangles in proportion or in the same ratio. I don't mind what you use as long as it's one of them. I want matching sides of similar triangles in proportion or matching sides of similar triangles in same ratio. So you can either use the word proportion or same ratio. Remember, fractions are ratios. You can write ratios as fractions. See, these are written as fractions. All right, it means that if you divide the length of PQ over BC and get a number, it'll be the same as dividing AP by AB. Now we substitute what we want. See, PQ matches with BC, AP matches with AB. So now I substitute the numbers in. So PQ over, what's BC? 27 equals 10 over 18. Now, whenever you make this statement up here, PQ over BC equals AP over AB, you must put the reason. Every time you make a statement in similarity or congruence, you must put the reason. So therefore, PQ, I need to get rid of this divide by 27. So I go, no, you don't need, you only need reasons for that. You don't need reasons when you substitute. Okay, you've made a statement here. Tell me why you made that statement. That's the reason. Now we just substitute in the numbers. No more reasons required. And what do we get? 15? Okay, good. So that's what PQ is. Now AQ is just doing AQ matches with which one? Same process. All right? Which one does AQ? So girls, notice I've drawn them. So AQ matches with which one?
AC.
Yeah, it's arc cross. Matches with AC is equal to, you can just do the same two again, AP over AB. So you do, one set's got one missing and the other set is complete. It's got both numbers. Whenever you set up an equation like this, you only want one unknown. I'm trying to find, I just found PQ. I'm trying to find AQ now, so that you write that first on the numerator. You don't write what you want on the denominator. You don't go AC over AQ, because then you've got the unknown on the denominator and that's a pain. We want the unknown on the numerator, top left-hand side. Reason, matching sides of similar triangles in proportion or in same ratio. What do you prefer, girls?
Did you say
Similar triangles in, what do you prefer, proportion or same ratio?
ratio?
Oh, well, choose. So, AQ over AC, 22.5 equals 10 over 18. So AQ, it's exactly the same working as before. Do you know what to do?
10 over 18 times 22.5.
Which is? Well, 10 over 18 is 5/9.
12.5.
Okay. And QC is obviously, you okay? Do you know what QC is?
22.
Isn't it? So you would write QC is AC minus AQ. See how I've set it up? QC is AC minus AQ. Does that make sense? So AC is 22.5, AQ is 12.5, therefore it's 10. All right, that was question 2.
What level would you say that was?
Not hard. Level, no, at least a level 3. probably a 3. It's straightforward. None of these are a level 2. Girls, you're doing the 5.3 course. 11.4 question 3. Prove that triangle QTR is similar to triangle STP. What I've done, all the markings are here. I've actually just put that these two here are vertically opposite. They're actually not included in the question. I've also drawn the two triangles that you're trying to prove are similar separately down here. So there's triangle QTR and here is triangle PTS. And you need to mark in all the given information. The QT is 7.2, RT is 4.8, PT is 6 and TS is 9. I've also marked in those equal angles, but remember they were not given in the question. So let's start the proof. In triangle QTR and triangle STP, what do you know? Let's start with angles.
Angle QTR equals angle STP.
So angle QTR equals angle STP. So girls, before you separated those two triangles, you needed to know that those were vertically opposite before you started. Otherwise, once you've separated, you won't see that anymore. So here, when two lines cross, always look for vertically opposite angles. So the reason that those two angles are equal is that vertically opposite angles. So vertically opposite angles. Angles. Okay, next. What else do you know? Now, which side matches with which? And how do you know how to do it? And I need another colour, please, someone. Pen, give me red, give me purple. Okay. Girls, 4.8 is smaller than 7.2. So 4.8 matches with which one?
6.
Yeah. So 4.8, thank you, matches with 6. And 7.2 matches with the 9. Girls, I cannot stress how important it is to do this. If you don't do it, you might get stuck. So,
How did you know that?
because I've got, do you agree that you think that those two are these two, but you're not sure of the order? 4.8 is smaller than 7.2, and 6 is smaller than 9, so the 4.8 must match with the 6. The reason is that similar triangles are the same shape, but one's just an enlargement of the other. So the smaller size in here is still the smaller size in that triangle. No, I go that RT, I'm looking at the ratio of RT over PT. Girls, I'm looking at the ratio. RT over PT is 4.8 over 6. Just get your calculator and do 4.8 ABC 6, or you make it 48 over 60 and then simplify. I think it's 4/5. 4/5. Girls, it's because 4.8 over 6 is 48 over 60 if you multiply the numerator and the denominator by 10. And then we know that these are both in the 12 times tables. 12. No? Yes, yes. So, no, you don't. Don't. No, you don't. You're just saying, no, you're just saying the ratio of that over that is this. You don't need it. Some people will give them, but it's not. It's not. Okay. So, girls, we're just looking at the ratio of this side over that side. I'm getting it's 4 to 5, 4/5. So now what can I do? The ratio of QT over ST is 7.2 over 9. 90. They're both in the 9 times tables, aren't they? So it's 8 over 10, which is 4/5 again. So girls, you can just put 7.2 ABC 9 and you'll get 4 fraction 5. Well, then there's a problem. And no, it could be that you've done 4. If they're not in the same ratio, maybe you did 4.8 with the 9 and the 7.2 with the 6 and did them and chose the wrong sides to match each other. Girls, listen. When you choose the sides, remember one triangle is just an enlargement of the other. So of course, the smaller side there is still the smaller side here. And the bigger side there is still the bigger side once it's been enlarged. Do you know what I mean? So if you remember what similar triangles are, they're the same shape. All right, you've got to find the matching sides. So therefore, girls, now we can say that triangle QTR is similar to triangle STP because look what we've got. Not two sides are equal. Two sides two pairs of matching sides are in what?
You say sides about.
Yeah, we can do that in a minute. Two pairs of matching sides in proportion, and what about the angle in between them? And included angle equal. Or you can use the rule, ladies, that says sides about equal angles in proportion. Shh. It means the sides that surround those two equal angles are in proportion. So the sides about this angle are that side and that side. The sides about this angle are that side and that side. It's the sides that surround the angle.
And we can say either one.
You can say either one. Okay? So two pairs of matching sides are in proportion. We can see that. And the included angle, or the angle between them, is equal. The angle's not in proportion. The angle's equal. Now, actually, keep the original diagram. It's better in this case. Are we okay?
Yep.
Actually, I'm going to move part B up here, where we've got some room. Yep. Part B is to hence prove that PQRS is a trapezium. What is the definition of a trapezium? One pair of opposite sides parallel. Ladies, having a look at that diagram, have a guess which sides you might think are parallel. What are the three tests? Veronica, you're on video now. What are the three tests for proving that two lines are parallel? What are they? How do you prove? What are the three rules associated with parallel lines? Alternate, corresponding, or co-interior? Which one is it, Vanessa? Go. Anna. It's going to be alternate, but before we say that, which two do you think are equal? Are going to be equal? This angle here and that one there. But before we say that, you need to say why are the angle at R and the angle at P are the same. So come back to the two triangles, ladies. Girls, we just proved that two triangles are congruent, these two. Let's start saying which angles match which. All right, this angle, I'm going to put a dot there. It's opposite the side with the circle around it. What's the matching angle in this triangle? The two triangles are similar. Similar triangles have the same shape. In other words, they have the same angles but different side lengths. Yes. Which angle matches that dot? How do you know? Well, it's in the same position. This dot here at angle R is opposite the 7.2, which has got the purple circle. No, we can't. No. Girls, all right, ladies. Alternate angles, I'll explain that in a minute. Alternate angles just describe positions. Alternate angles aren't always equal. No, they're not always equal. They're only equal if the lines are parallel. I'll demonstrate in a minute. What I want to do, now that we've proven that they're similar, the dot here opposite the circle with the 7.2 is the same angle as this one. And this angle here with the cross must be this one. The angle there with the cross is opposite the 4.8 with the purple underline. The purple underline is here. That cross matches that cross. So what I've done now, I've matched all the angles. So I'm going to transfer those dots to this top diagram. So R's got the dot and P down here's got the dot in there. Are we okay with that? Yeah. And this one up here's got a cross and that one's got a cross. Okay, so I've transferred everything back up here. So the dots are equal. So what I'm going to say here is in my two congruent triangles, the similar triangles, sorry, I'm going to say angle QRT is equal to angle QRT equals angle SPT. Why? In these two triangles. Why am I saying that dot there, have I done it wrong?
Is it matching?
Yeah, matching angles of similar triangles. What I'm saying, girls, listen. Once you've proved that two, yes I have. I've just proven that these two triangles are similar, haven't I?
Wait, so similar angles have
Girls, similar triangles have the same shape but different sizes. Similar triangles have all angles equal, like they're equiangular. So that's the idea. If two things are similar, they've got the same angles, but the side lengths are different. That's all. So therefore, that angle equals that one, this angle equals that one, but I don't need to do both. I'm going to say, well, that angle there equals this one. I put it back up here on my diagram because I know I need to do alternate. So I've got that those angles are equal, matching angles of similar triangles, and I can say angle QRT is alternate. It's in an alternate position to angle SPR. Now, I'm not saying they're, so if you look at the diagram up here, they do form the Z shape, angle QRT and angle RPS or whatever it is, okay, SPR, they form an alternate angle, the backward Z. So therefore we can say that QR is parallel to PS. Why? Because those alternate angles are equal. Alternate angles are equal. So therefore, because I've now proven that QR is parallel to PS, therefore PQRS is a trapezium because it's got one pair of opposite sides are parallel. Now, I'm going to explain. One sec. Well, no. The minimum, if you've just got one pair of opposite sides parallel, that's the minimum amount of information you need to know that it's a trapezium. Now, while you're writing that, I'm just going to play around a bit down here, and I want to show you some things.
Did you copy this down?
Watch. See the arc and the cross in the first diagram? I want everyone looking here. They're alternate. But do you think they're equal? These are alternate as well. But these ones are equal because the lines are parallel. So alternate angles are only, alternate is just a name describing the position. So these two angles here are alternate, but they're not equal. Why? Because those two lines aren't parallel. But here, these are alternate angles and they're equal because the lines are parallel. So if I call this one A and this one B, A does not equal B here, but here, A does equal B because it's on parallel lines. Now, if I've got A and I call this one C, they're still corresponding A and C, but they're not equal. But here, A does equal C. Why? They're still corresponding as well, but they're equal because the lines are parallel.
Wait, so what makes it equal? Because the lines are parallel?
Yes, that's it, because the lines are parallel. So alternate, corresponding, co-interior just describe positions. The only time that they're equal is when the two lines are parallel. Does that make sense? All right, so alternate, corresponding, and alternate and corresponding aren't always equal. They're only equal if the lines are parallel, which is why up here, this is my test for parallel lines. I've identified the alternate angles, and they happen to be equal. So therefore, those two lines are parallel. Do you get the idea? And like, if I look at B and D, co-interior, in this first diagram, B and D don't equal 180. But if I look at the second diagram, B and D do equal 180. Why? Because the lines are parallel. B and D are still co-interior here, but they don't equal 180. Does it make sense? So, don't always think alternate angles are equal. Don't always think that corresponding angles are equal. They're only equal when the lines are parallel. Now, girls, size 11.4, question 4, you know that ABCD is a parallelogram, and you have to prove that triangle DEF, this small one down here, is similar to triangle AEG, the larger one there. I would be putting in parallel line symbols on my diagram.
Are you allowed to do that?
Yes, because you're told that it's a parallelogram, you know what's the definition of a parallelogram? Two pairs of opposite sides parallel. So them telling you it's a parallelogram is telling you mark in the parallel sides. Obviously, you're going to use stuff like alternate or corresponding, more than likely, not co-interior, you don't tend to use it. You don't tend to use it because you end up with two angles that aren't the same. Do you know what I mean? Alternate angles are equal, corresponding angles are equal, but co-interior add up to 180. So you're not going to tend to use that one much in similarity or congruence. In the parallel lines, we can see we're trying to prove that this small triangle here is similar to that large triangle there. We know that E is a common vertex, so the angle at E in both triangles will be the same. When you've got parallel lines, you're either going to look for alternate or corresponding. If I do alternate, I end up with an angle outside my triangle that's not going to help me. But if I look at corresponding or F angles, I can see that this angle here at A equals this angle down there. You can also have done a backward F. So this angle there at G is equal to this angle there at F. So we can see, looking at the small triangle and the big one, that you've got similar by what rule? Equiangular. So let's start writing it out. So A, in triangle DEF and triangle AEG, what are you going to do? Angle. Which one? Let's do the arc angle first, this one at E. What do I write?
Angle DEF is common.
Equals angle AEG. And you can just write angle E is common. You would get the marks. Reason angle E is common. What else? It's all marked there, girls. You've just got to write it out. Angle, no alternate. Yep. All right, girls, the first triangle has to be with the small triangle, DEF. So angle EDF is the dot. Describe the dot in the other one. EAG. Did you get that? EDF, EAG. Reason. Why does EDF equal EAG? Corresponding angles. AG or AB is parallel to DC. I just write down here that AB is parallel to DC and AD is parallel to BC. All right? All right, that's enough. You don't have to do the crosses. Okay? Girls, for equiangular, you only need two angles. So this time, we're not going to do the third angle. Therefore, triangle DEF is similar to triangle AEG. Reason? Reason? Equiangular. Shh, ladies. Excuse me. Now for part B, you have to find AG. This is where I would draw the triangles separately.
Attention everybody, in the next bell you will hear.
Drawn these two triangles separately with the corresponding angles in their places. We're marking on any side lengths 4 and 3. What's the length of AE? And AG is the one that we want. So, girls, the one that you want, you write down first. AG, where's its match? Dot cross. What's the match for AG? What's the matching side for AG? Thank you. Equals. Now you choose another pair that you know the two numbers for, the two side lengths for. So AG over DF equals A, come on, that over that. So we're going from right to left equals right to left equals these two match. So girls, these two match and this one matches this. Because it's between dot arc, dot arc. Girls, that's how you identify where the side is. Dot arc, they're matching. Does that make sense? All right, in a minute. Equals AE over DE. Reason, why are you writing this down? Matching sides. Matching sides of similar triangles in proportion. So AG over DF equals AE over DE. Reason, matching sides of similar triangles in proportion. Replacing any of those side lengths with numbers. AG over 3 equals 12 over 4. Girls, you can see what's happening here. I don't mind if you just go 4 times what is 12? Tell me. 4 times 3. Tell me what the answer is going to be.
9.
Yeah. So you should get 9. So AG is 12 over 4, which happens to be 3. times 3, which is 9. However, if you did say that AG was 9, you'd need to say Y. So you really do have to do the ratio. All right? Okay, girls, that's question 4. The next one we're going to look at is, sorry, I'll just move it over the side, perhaps question 5. All right, this is a good one.
How do you draw that?
I would just do, can I, you got all that now, girls? All right, I'm going to do question 5. Just draw, I'd go like this, and then like that, and like that. I went like that, like a greater than symbol, and joined the other two. We've got U, V, W, X, and Y. Putting in the side lengths, we've got 5, 3, 4, and 2. You have to prove that triangle WUX is similar, sorry, I'm just going to bring the question over, similar to triangle WYV, and then you're told that if UX equals 7, find VY. That's question 5. So I'm going to move that down here now. Hopefully you've done the other question. All right. Come on, we've got to get more than 3 questions done in the whole lesson, girls. Prove that WUX is similar to WYV. They are overlapping, but make sure you can see what the triangles are. Can you see anything, girls? I'm going to draw them separately in a minute because even I'm getting confused here. But tell me, if you look at them and outline them, can you see an angle that's the same in both of them? Is there an W? So now that you can see that W is in the same place, yes, that's going to go in my proof, but I'm going to draw them separately now. So I'm going to go U. It's just going to make it easier. That's my first one. And my second one looks like this. Shh. And can we put in some side lengths? What's UW? So these are the two that we're trying to prove, WUX and WYV. So I've drawn them separately. Let's put some side lengths in. That one's 8. Do you have anything else? Do you have WX? Yes, 4. Do you have WY? WY? 6. Do you have WV? 3. Good. And what's the angle that we marked before? Okay, can you see what you can see?
Yep.
You can see that it's going to be 2 sides in proportion and included angle equal. But, yes, we can see that, but let's match the right sides. 4 is the smaller one here. What does it match with? Matches with the 3. 8 is the bigger one here. It matches with the bigger one here, the 6. You're all ready to go now. All right? We can see the 3 pieces of information. The only one that doesn't need 3 pieces of information is equiangular. All right, let's start. So, part A. Come on, girls. In triangle WX and triangle WYV, what have we got? Angle. Now that they're drawn separately, you can name them properly as well. Angle UWX is equal to angle VWY. Why? Why is that so?
Common angle.
Angle W is common. Shh. Now what do we do? Well, I do the matching ones now. I do the ratio of the matching ones. So, XW I know matches with which one? I've circled them. VW, and it equals 4 on 3. Don't go and write 1 1/3, please. It's a ratio. Keep it as a ratio.
So we need reasoning.
No, not for that. You're just saying that over that equals that. Now, girls, please. I'm going from the left to the right. This one over that. I need the same way. That over that. UW over YW is?
8 on 6.
And simplify that, dividing them both by 2.
4 on 3.
Great. So we've got, therefore, triangle WX is similar to triangle WYV I've got two pairs of matching sides in proportion. Girls, do not pack up. And included angle equal. And I'm running out of room. And the included angle equal. I should have just written sides about equal angles in proportion. Two pairs of matching sides in proportion and included angle equal. Now for the last bit, if ux, it says if ux, this one is 7. So girls, they're saying if this equals 7, find vy. Are they the matching sides, by the way? Yeah. Okay. So if you want to find vy, so you go vy over 7 or ux. So I'm going from there to there. Just choose another 2. Equals 3 over 4. So that one to that one equals 3 over 4. All right. All right. Sorry, girls. Just have that door closed, please. So we've got, that over that equals VW over XW. Reason. I'll just put them in. That over 7 equals 3 over 4. I'll write the reason in a sec. And then times it by 7. And 3/4 of 7, it's 21 over 4, which is 5 1/4, I think. Yeah. So the reason is, why am I making this statement here? Matching sides of similar triangles in the same ratio or in proportion. Okay? So I went that over that equals that over that. Reason, matching sides of similar triangles in proportion. Did the substitution and worked out the VY. Ladies, shh.